All right, thank you, Rolanda. Thanks for that introduction, but I'm going to ask each of you to do a little bit of a 30 seconds, no more, introduction of who you are, what you're working on, and then we'll jump into questions, but let's start with the easiest one first.
Yeah, I'm Vijay Karunamurthy. Up until recently, I was running engineering and product at Scale AI, which is, as mentioned, one of the largest infrastructure companies, particularly focused on data used for training reasoning models, agents, the next generation of frontier models. Before Scale, I was at Apple and Google and led machine learning teams there. But I'm currently at EAR at Coastal Ventures and thinking through ideas for RL in the real economy and ways to make agents more reliable.
Okay, hello, Noah Smith. I'm a professor of computer science at the University of Washington. And I'm also a senior director of research at the Allen Institute for AI, where I co-direct our efforts to build open language models like OLMO, the fully open language model.
Hi, I'm Jonathan Cohen. I'm at Nvidia. I've been at Nvidia since 2008. I've kind of worked across the whole stack. I started mostly as a CUDA developer. I ran the CUDA math library team for a long time. I spent a few years at Apple. I came back to Nvidia, and the group I lead now is more applications. So now I'm one of the two leaders for our Nemotron program, which is our large-scale frontier foundation model training program, among a few other things.
Great, thank you. So last panel, we heard from enterprise leaders around AI adoption or some of the blockers there. Can we take the infrastructure perspective on that? What do you see as the biggest barriers to enterprises realizing value from AI? Is infrastructure the main blocker? Is it something else? Noah, do you want to get us started on?
Sure. I'm not sure I'm the right person to talk about infrastructure. I guess as a researcher, I still see that in research and development, I think there's a huge gap. In fact, I would even call it a crisis in the way we evaluate the quality of what we're building and its usefulness. And so like what actual users, like the people in that enterprise, want to do in their work and where AI is maybe going to be helpful for them, that doesn't line up well with what we measure when we're building the systems. And so I guess I would summarize maybe one of the blockers is probably like trust. Do people believe this is really going to do what it needs to do for them?
Does anyone have an infrastructure thing they think is a blocker? I mean, I know when we were talking beforehand, a lot of us feel like the blockers to adoption are really how to realize value and behavior and how to integrate AI into people's workflow. But are there infrastructure things that are blocking now?
Yeah, I think so. So, you can get access to hardware. I mean, other than shortages or whatever, but
Whose company has shortage?
Yeah, that's a very complicated topic. Not my area really, but there's plenty of GPU servers available. I think, and there's low-level software available to run like VLM or like these kinds of packages for running inference or training. But I think there's like this layer in between, which is if you want to actually take some AI use case, some model, some inference, some fine-tuned thing, whatever it is, and actually go build the infrastructure, deploy it at scale within your enterprise. I think there's a lot of opportunity for software to fill that gap. It's still quite hard to do today, especially when you think about like, and some of what we'll talk about more, these more complicated systems where you're collecting usage data and using that to improve the agents over time. I mean, the plumbing of this kind of stuff, especially when you need to think about compliance and governance, is extremely hard. And I think there's a reason why very few companies have actually adopted it today.
Let's talk about that a little bit. I mean, there's a ton of focus for all of those reasons right now on model refinement, fine-tuning techniques, and what's changing. Vijay, we're probably asking you to go back into your last job before your current job, but
Totally.
Can you walk us through what's changing and where the largest gains are, where we're still falling short?
Yeah, just a key insight that things were directionally changing. It came for us in January. So we launched a benchmark called Humanities Last Exam, which was very provocatively named. We basically went out to people that were experts in given fields across a huge range of fields like archaeology, botany, areas that you don't necessarily associate with like AI progress. And we asked them for the most difficult questions that they could possibly ask in those fields. And it turned out when we launched this benchmark, every single model flunked. There's not a single model that got over 6% on our first release of the benchmark. It was just beyond what most models were capable of addressing. But what we realized when we digged into the loss patterns, why did the models fail? What were they struggling with? They realized that the humans that were able to answer these questions, they were really leveraging search and really interesting, diverse ways. They might search an area that was within their field and they knew enough about how to phrase that search query. They could find the right journal articles. They could translate the results into maybe code execution if you're solving a math problem. They could do things that within their field were at the frontier of their capabilities as humans. And we learned a lot from that about the direction where reasoning models were going to go. So it turns out today there are now models that score 20% on this benchmark. So we're still kind of failing as an industry, but we're getting better. But the ones that are making the most progress are really rethinking the nature of what it means to solve really difficult, complex problems. It's focused on parallel execution of search, doing many, many search queries at once, slightly revising those search queries based upon what you know about that field, doing code execution in many, many different ways, and then hopefully over the course of an hour or 2 hours of work, making progress towards a problem that previously was intractable for the previous generation of models.
You know, obviously there's been a lot of focus on reinforcement learning with human feedback in terms of how to refine models. Noah, how important is that as a technique, and what other techniques do you really rely on when you're doing your work?
Yeah, so I mean, reinforcement learning of many varieties. I think the hot one right now for us that we're really excited about is reinforcement learning with verifiable rewards, which in some cases where you can get a very clear right-wrong signal and don't need a reward model, that seems to be working really well. I think, you know, the opening up of these algorithms to more people who are going to fine-tune their own models or do reinforcement learning with their own verifiable rewards or their own human feedback, whatever. To me, that just reflects back to the biggest lesson that we keep learning over and over and over again as we build these models, which is the data. It's always the data. And the quality, not just the amount of data, but the quality of the data and your choices of what you curate and what you use. That is more and more people, I think, are gonna realize the potential of what they can do with their own data when they have access to these algorithms, whatever algorithms they end up being. I'm an algorithms guy, so I get excited about the algorithms, but the data matters more.
Can we talk a little bit about algorithms and models? Jonathan, you were mentioning, you know, that you lead development of NeMo at Nvidia and co-lead the Nematron family. I know you're going to be unhappy with me for saying this, but a lot of people in the audience think of Nvidia as a chip company. Why are models a critical focus for Nvidia, and why make them open source? Why is that important?
Well, I'm just going to channel Jensen here. You know, we're not a chip company. We're an AI infrastructure company. And AI infrastructure is more than chips, certainly. It's data centers, it's network, it's you know, all those the hardware components in between. It's layers of the software stack that give you access to all of this. It's performance libraries like cuDNN, distributed performance technology like Dynamo, which is our system for disaggregated serving. But it also, I think, has to include models. It has to, you know, the entire stack. And so if you think about accelerated computing as what our business is, accelerated computing means someone has a problem to solve that is computationally challenging, takes a lot of compute power, but it's valuable to solve. And so we give you a solution that solves that problem faster and therefore delivers more value. Well, if all we have at our disposal is to make a better chip, we're limited in how much faster we can make the solution. If we can adjust the chip and also the software, with this multiplicative effect, and we can co-design things together. If we can adjust the chip and the software and the models and the algorithms, the entire stack, we just have a lot more opportunity to accelerate things. And ultimately, what you care about isn't necessarily this model or this chip. You care about time to solution for the problem I care about. And NVIDIA has always taken this approach, you know, as a gaming company, as a high-performance computing company, as an AI company, or deep learning company, and now like modern AI. I think the secret to our success has been that we've always been a full-stack company, and we've always thought about accelerated computing from this perspective of full stack. And so this is just a very logical extension, I think, to the philosophy we've had for 30 years.
We can drill down a little bit more into the open versus closed debate. No, obviously, you know, AI2 is a nonprofit research lab, so it makes sense on some level that your model work would be open source. But more broadly than that lens, why is it important for at least some frontier models at the, you know, absolute edge to be open?
Yeah, so I think the first answer I always give to this question is the scientific one. So we all like progress in AI. We know that originates with people in research labs, whether in companies or in universities, being able to study the phenomena, being able to study the models, being able to study what they can do, what they can't do, and get deep inside. And up until 3 years ago or so, that was the norm in computer science research, was that if you wanted to study the latest things in machine learning and artificial intelligence, natural language processing, everybody was talking very openly about what they were doing. And it was really kind of chilling when there was this turn towards these things being treated as trade secrets. And I think it's a huge lost opportunity if you have no version of these things that's fully open and can be inspected by our best scientists for scrutiny and looking for opportunities to improve. So I think if we want to continue scientific progress, one of my friends likes to say that studying current AI through the lens of proprietary models is like trying to do astronomy research based on pictures of the night sky printed in the newspaper, right? You get a really grainy image. You just can't see very much. And I think a lot of information is actively protected. So scientific argument is one. I think also having an open, we like the word ecosystem now, an open ecosystem of artifacts that you can touch any part of the pipeline and make changes as a developer or as an innovator. I think that is way more empowering, similar to open source software. So those are, I think, the two biggest arguments for having open options.
Vijay, sorry, go ahead.
Can I just add to that?
No.
I think, from the perspective of NVIDIA, if we have an innovation at the model architecture level, let's say that makes an LLM faster at inference time, the easiest way for us to disseminate that is to open it and to share it with everybody. And if one of the frontier labs, companies that have a proprietary API as their product adopts our technique, we're thrilled too. But also if some, a sovereign AI effort or some small company takes our model with these techniques and builds on it, that's also great. So I think from our perspective, this open ecosystem and disseminating ideas in this open way, is a very natural fit for our business and the way that we go to market and the way that we partner with the whole ecosystem. So, that's one of the reasons you see NVIDIA has become a very strong contributor to open weight models. Nemotron, I think one of the things we are committed to is actually making Nemotron like the most open of open weight models that, possible, sharing data sets, sharing training algorithms, sharing everything we learn. So you should expect to see NVIDIA being more prominent, I think, in this ecosystem going forward.
Vijay, can I ask you about this from a competitive standpoint? So obviously OpenAI, recently released an open weight model. At the same time, Meta seems to be pulling back from their open work. And when I talk to companies in the US and in Europe, what I hear is that the best open models are the ones coming out of China. Is that a problem for US AI development? Is it a problem for national security? What are the obstacles to strong open model development in the US?
Yeah, I think yes and no. And Noah brought up RLBR as a technique. That's a great example. We learned a lot from China publishing some research earlier in the year. When DeepSeek published the R1 paper, they actually revealed a lot about this GRPO method they use for training their model that you can almost write on the back of a napkin. It was such a simple idea, and yet it kicked off like this huge wave of progress over the course of the next couple of months. So we're learning a lot by them, sharing a lot in a more open way, and it's really kind of kickstarting a lot of research efforts here. But from a no perspective, I think there's really great incubation of talent happening there in China right now, all within kind of the Palo Alto of Shanghai, where a lot of these researchers are focused. We don't necessarily have that kind of level of investment right now here. And so it's great to see like Ellen Stu for AI, like a few players like really just pushing the field forward in the West and showing like how much we can learn from the Tulu 3 family models, other family models. And there are really important open science problems that are out there that we're going to learn over the course of the year by just doing more of this work in the open. The biggest one might be like scientific discovery. I think you're starting to see a category of startups trying to push to find out new superconductor materials or new thin film deposits you could find. Scientific discovery seems like a very different task than a lot of the previous tasks we've asked these models to do, compared to a model in the past which tries to get you to the one right answer you need as a human. Instead, here you need a million different possible candidates of superconductors that you're going to try in a simulation really quickly. Diversity and creativity is really the name of the game of how those models are supposed to operate. It's just so different from the way we've thought about models before that we need a lot more open publication about how to achieve those goals.
Jonathan, you were talking to me about something you referred to as sort of flywheels or self-healing agents. What is that concept and why is it important in model development?
Yeah, so I think of like the best analogy I have is human employees. So everybody has this experience. You hire somebody, and you expect them to get better at their job the more they do their job.
Are you like Marco? You prefer to manage AIs and
Well, I'm not saying that, but this is a nice quality that humans have, most humans have, that they do their jobs and they get better. And this is what managing is, right? That's why we pay senior people more than junior people. Presumably they're more valuable. My belief is all production AI systems that deliver value have to have a mechanism like this built in, because they're all going to start out being okay at some things and not so good at a lot of other things. And there has to be a natural mechanism for them to improve over time. So you could call this, I like to call this like a flywheel, in the sense of, you start it spinning and it sort of spins more, right? The more you use, and you would like an AI system to have this property that the more you use it, the better it gets. And then naturally you use it more and it gets better, and so on. And imagine, any AI system that has that property will eventually be really useful and really valuable. The engineering around that is really hard. I mentioned earlier, it's not necessarily you need to collect data and fine tune a model. That's one way, but collecting data and just using it as validation data for tweaking the prompts, or distilling a model and making, could I replace this expensive model with a smaller model? Or there's all these different ways in which you can improve things over time. But in general, they all require somehow capturing usage information, capturing signal about, did it do the right thing or not somehow, being able to deal with all of this data in a way that's compliant with privacy and all the regulations that real enterprises have to deal with. Deploying things, A/B testing. There are certainly big companies that have deployed flywheel systems like this. Facebook recommender system for newsfeed is a good example of something that delivers tremendous value. But those systems are really hard to build, and they're really hard to build at scale. And I think until we see better software infrastructure that allows that to happen, you're just not going to have a lot of these systems deployed. But I think that's a super important problem. It's something we work on, something we think about. And I think it will be an enabler of an awful lot of agentic employees, if you want to call it that, actually being put into real production in the world.
Vijay, do you have thoughts about, are there ways to design models to create that sort of flywheel? I know you mentioned a basic example to me in coding.
Yeah, there's a really interesting one that Cursor does now. So Cursor, in addition to using, you can use Anthropic's Claude 4, other models, they have a tab model that powers this feature of tab autocompletion. And that feature's been around in IDEs for years and years. Most programmers didn't used to use it before AI because it was really bad. You would always try to tab autocomplete and it would be something that was totally off base for what you wanted. But now with AI, it's gotten pretty good. And the real innovation that Cursor had is they can learn through online RL what the coder's preferences are about what they want to see within that tab autocompletion, and literally just ship down new model weights all the time to individual developers so that they're able to operate, or just version that on the server. This kind of online paradigm of you're getting user feedback, you're adapting to it really quickly. If you own the application surface area, you have that opportunity, and I think you're going to see a lot more investment and innovation happening in that going forward.
Since the release of DeepSeek R1, there's been a lot of focus on mixture of experts as an approach. Where is that approach most useful? Where is it not? What other techniques are emerging?
Yes, I think mixture of experts is exciting first because it can speed up training. It's got efficiency properties that are sort of appealing if you're building models. If we can train faster, we can test more things, right? We can build more models, or maybe bigger models. But I think one kind of exciting thing that's happening there is the realization that you don't have to train all of your experts at once together. So we have a new approach we call FlexOLMO, where after you've trained your basic model, you can have new experts added later, asynchronously specialized on different sources of data. And this can actually end up working better than if you had all the data at once and trained in the usual centralized fashion. So this opens up the possibility not just for specialized experts, which I think are going to be really important in the future, but also kind of coordination without sharing data. And so this is actually something we're exploring inside the Cancer AI Alliance that was mentioned earlier today. We think this kind of technique, architectural developments based on the idea of mixtures of experts where experts can specialize, I think is going to be extremely powerful. And I'm really excited to see where that goes, even in multimodal space.
We just have a couple minutes left, so I'm going to ask each of you what you expect to see going forward in the infrastructure evolution. what are you most excited about in the next 12 to 18 months, Vijay? Why don't we start with you? We'll go down the line. Most excited about?
Yeah, robotics is obviously huge and making a lot of progress. And you have startups like Physical Intelligence, they're training VLA models from scratch. The data requirements there are truly insane compared to other forms of AI training, because if you even think about it, a single robot collecting data from multiple cameras, synced together, multiple sensors, from a given facility with even like a dozen of those robots, you're easily sharing petabytes of data over the course of a day. So it's just crazy to think about the data requirements and the needs there for training the next generation and improving slightly on how well those tasks generalize. But we're seeing a lot of progress over the course of the year.
Yeah, a couple of things. I'm really interested to see kind of the development of new architectures and kind of a move away from pure transformers in a lot more settings than we were seeing. So I think diversity of approaches is really good, and that's starting to look more healthy. And I think that's going to have a big impact specifically in multimodality. And by multimodality, I don't just mean pictures or sound and text. I'm starting to think, you were mentioning scientific users. I think scientific data is going to become really important, and we're going to see scientists able to develop their own multimodal components for their data, whether that's time series or geospatial or something completely different.
I guess one thing I mentioned is, at Nvidia, as the creators of a lot of infrastructure, we have an internal mandate to use AI to make our engineering more efficient. So we're using, LLMs and agents, modern agents for chip design. We're using them for software engineering. I think at this point, the majority of software engineers at Nvidia use AI coding assistants in their daily workflows. And the reason why that's important is the infrastructure that we're building is getting more and more complicated. Modern data centers and the software stacks are getting incredibly complicated. And for us to maintain the pace with which we've been developing software, we somehow need to boost our own productivity, right? And so I think, and we have examples already where AI accelerated tools are making our engineers measurably more productive. And I think that compounding effect is going to be really interesting to see play out over the next year or two.
Great. That's all the time we have. Thank you for joining us, and thank you, Jonathan, Vijay, and Noah.